Hello techies, welcome to IT Tech Solution. To continue with this Spark learning series, today we will see few of the basic concepts of Spark. We will also see the architecture of Spark and few very basic building blocks of Spark, like for example, what is RDD, what is a driver program, what is executor, how the application flows when we submit a Spark submit command. So all these things we will cover in this tutorial today. We will also see what a DAG is, what is lazy evaluation, and what are actions and transformations, a basic example of it. So let's begin with an example. So before directly going to the Spark application architecture, first let's see a sample example where what happens exactly when we submit a Spark application. So it will give us a little bit of insight what happens internally, and then we will cover the different topics separately. As soon as we submit the Spark application, uh, it runs on its own JVM. Okay, and this JVM is responsible to create the Spark context. So I will explain what Spark context is. For now, it is you can understand it is just an entry point for the to access Spark APIs. So without creating a Spark context, we will not be able to create any data frames. So then this creates a Spark context. Okay, and once the Spark context is created, it accesses the different transformations or the different codes, different commands that we have written in the Spark application. Depending on the number of partitions the corresponding data is residing into, this Spark context will ask cluster manager. Okay, so cluster manager is responsible then, depending on the number of partitions, it will assign the resources and it will create those many number of executors. So for example, if my data is present in three partitions, it will create three different executors. Okay, and all these different executors is nothing but the slave nodes or the worker nodes which has a cache memory inbuilt into it. So whatever data that it will process, each of these executors will process, it will save them in the cache memory. No data will be transferred back to the driver program. So here this one is the driver program, and these are the worker programs or the worker nodes where the tasks will be running. Now, once executors are created and the executors are assigned, then the Spark application will send the tasks, okay, to the corresponding executors. So what happens is it cluster manager identifies where the data is residing on which worker node, and it sends the request to those nodes and it sends the task to perform the transformation that we have mentioned in the program. So for each of these executors, separate tasks will be running. And as you can imagine, right, it will be all running in parallel. And once it is executed, it will store the data in memory for each of these executors, and it will transfer back only when we have some action. So as soon as some action is performed, then only the final result will get combined and then it will be sent back to the driver program. So just for now, we will remember that Spark follows lazy evaluation. Lazy evaluation means it won't be sending back any data or there will be no data transfer until and unless it sees an action. Until and unless it has only transformations, it will do all those computations and keep the data in the memory. This is how the entire application works. So now we will see the different concepts of Spark one by one. So this is the Spark architecture. As now, just now we have seen, right? It is a master slave architecture. It converts the program into tasks. Okay, and all these tasks are sent to the executors. And here in executors, these tasks are performed and it is saved in the memory for each of these worker nodes. And then these worker nodes, when it performs the action, it sends back the combined result to the driver program. And the function of cluster manager here is for managing and allocating all the tasks to each of these worker nodes, identify based on address of each of the data where it is stored, in which nodes it is stored. It sends the task to the each node. It also continuously monitors the health of each of the worker nodes, and if there is any failure in any of the worker nodes, it replaces them with another worker node. Now, when the program finishes, or when there is any failure, or when the program is stopped, right? The Spark session is stopped. The cluster manager releases all the resources, and then the executors are free to take up another task from some another program. So this is what the basic architecture of Spark is. Next, we will see RDD, transformation and lazy evaluation and action. Okay, so RDD is a collection of your records. Whatever transformation we are doing on any data, it creates an RDD from that. Suppose first RDD, we just are reading a set of data, so the first RDD will get created, and that RDD will have the complete data in it. Now from this RDD, when we create second RDD, apply some transformations on it, or apply some filter logic on this RDD. Suppose we are out of 10 columns, we are just taking 5 columns. So it that transformation will create a second RDD, and that second RDD will be having only the records related to the those 5 columns. So this way second RDD gets created. So in this way the entire program is divided into different RDDs. All these RDDs internally will have different partitions, and each partitions will be processed in a separate task in the separate executors. So this is how RDD is created, and all of these things gets processed parallelly in the different worker nodes. So this is RDD. It is a building block of any Spark application. It is simple like a variable, but yeah, it is a resilient distributed data set which is immutable. Next thing is transformation and lazy evaluation. For example, if we are applying any filter, or we are doing some date logic, changing some logic in the date, the format and all, right? All those are transformation. So maps, filters, and then all these kind of selecting few columns, removing other columns, adding new columns. So all these are kind of transformation, and these transformations does not perform any data transfer. So as I said in the example application, it does those transformations and keeps them in the memory of each of those executors. So that is what transformation is. And lazy evaluation means it will not transfer any data, or it will not do the actual processing until and unless it encounters an action. Okay, and actions are for example the commands or the APIs like collect, count, save text, save as text file. So whatever needs to fetch the data, actual fetching of data is called as an action. So after the RDDs are created and all RDDs are doing some or the other transformation, and at the end we would want to save this file, or maybe we want to do a count, or even we want to collect it as a list or something, right? So all these things is termed as action, and as soon as action is performed, it triggers the execution of the DAG, okay, or the computation plan that it has created. Okay, so that is where this DAGs also comes into picture. So for now, we just will remember that Spark follows lazy evaluation, and the actual data transfer or all the DAGs or all the computation, it happens only when it encounters an action. The next thing, as I said, is DAG. It is a sequence of transformations that the Spark application has to do. As soon as we do some action, then uh, those transformations and everything will get executed, and finally it will return the result to the driver program. So here you can see a sample DAG where it is creating the different tasks into stages, and each stages is having some or the other transformation it is doing. Okay, I will explain in more detail what a stage is and what a tasks is in the next few slides. But for now, remember that DAG is the sequence of transformation that it has to do. So next we will see is stages and tasks. As I said, right, RDD is the building block or the complete set of data. The first RDD will have the complete data of the partition that we are reading, or a complete data set that we are reading, and that data set is stored in a distributed fashion. So Spark is everything, we know that it is a distributed framework. So any data set, it gets divided into small chunks of data, and each partition is then saved into a different node. So each data is replicated into multiple blocks, and then each of these blocks are saved into different nodes. So when we are reading any particular data from the cluster, it will read those records as partitions. So out of maybe 100 records, 30 will be saved on one node, next 30 will be on some other node, next 30 on some other node, and last 10 records on some other nodes. So when we read this complete data set, we will get a total of four partitions: 30, 30, 30, and 10. Okay, so one RDD, it comprises of different partitions. From whichever nodes it is reading, it will create those many partitions in it. Okay, and for each partition, when we trigger the transformation, that means when we perform some action, what happens is those many tasks are created here. Okay, for each partition there will be a task created, and it will be assigned to a node. Okay, this will be assigned to node 1, and maybe this will get assigned to node 2, and similarly third one will be assigned to node 3. So in this way, different tasks will be executed on different nodes. So depending on the number of partitions, the data is stored in the cluster, that many number of tasks is created, and the tasks are sent to that node to fetch the data. Okay, and at the end, when the action is performed, it combines all of these results from these three tasks, and then it sends back to the driver program. So here we can see now the tasks are divided based on number of partitions, and a combination of all these tasks is combined into a stage. Okay, and there can be multiple stages as well. There can be one stage, two stage, five stages, or 10 stages. It depends on the type of transformation that it is doing. Now there comes a concept of narrow transformation and wide transformation. I will explain those things in the future lecture, but for now we will just remember that the group of tasks is called as stage. Next thing is the Spark session. The first thing the application does is it creates a Spark session. Without the Spark session creation, we cannot call it as a Spark application. As soon as it creates a Spark session, the internal APIs and other Spark functionalities is available to the program. So creating of Spark session is kind of entry point to the Spark itself. Okay, and using this Spark session, we can define the app name, the master where it will be sending back the data to. So all these things can be defined using the Spark session object. So here a Spark session is the entry point to any Spark functionality. It provides the convenient way to interact with Spark. uh, and I'll come to this point at the last. Spark session is used to create all the data frames. So without, as I said, right, without creating a Spark session, we'll not be able to create any data frames or execute any SQL queries or do any processing. It will not be executing at all. So we typically create the Spark session using this Spark session.builder API. With this, we can create the Spark application using the get or create method. And get or create method functionality is if there is already a Spark session already executing, it will give back us that Spark session. It will not create a new one. But if suppose the Spark session has already stopped or terminated, then it will create a new Spark session. And in master, we when we are running the application on cluster, we need to give the master URL, or maybe we can pass it in a variable or anything. We should not hard code the a URL of the master node. Instead of that, there are various methods we can apply, but we should not hard code, because if there is any change in the cluster, our program will start to fail, right? So there are methods we can pass the actual master URL instead of hard coding it here. So this is all about Spark session, and any Spark session can be stopped using spark.stop method. Now, coming to this point, earlier what was there before to Spark 2.0, we had to create different contexts for SQL, different context for Hive, and a separate for Spark context. Okay, but with this Spark session builder get or create method, it has unified all of them all together. Now we don't have to create a context for SQL separately, for Hive separately. Using the same Spark context, we can use either of these contexts, and we can run the queries, or we can connect to Hive application or Hive database. So this way it has unified these three contexts together. There is also one more parameter called as Spark conf, that we can create an object from Spark conf API. Okay, and we can then set the app name and set master, similar to what we were doing for Spark session. So the use of this was to set some of the fine-grained parameters that we want to set for the Spark application. We can set few parameters related to Spark configuration using programmatically using Spark conf. In practice now, if you see, we when we're working with Spark 2.0 and later, we don't basically use these Spark conf anymore. Most of the things is handled by the Spark session these days. But still, if we want to fine grain some of the parameters or some of the configurations, right, we can use the Spark conf. Configuration properties can be set using the set method on Spark conf before creating the Spark context. And Spark conf is typically used to specify Spark related settings, and any parameters that we want to set here, we can use the Spark conf parameter. So this was about the Spark conf and Spark session. These are the basic concepts of Spark and the building blocks of Spark, I would say, and it is important to understand all of these. So that was all for this lecture. I hope you must have liked it. I will continue the future lessons on other PySpark topics, and we will soon see some coding, and we will try our hands on some of these Spark commands.